I made a small timer to help my daughter train for taking a multi-sectional test in a few months. It is made from readily available parts and an Arduino sketch I put together with help from various examples on Github, as I'm still learning how to construct sketches for Arduino. It is intended as a training tool, so simplicity and ease of use were the key considerations. I went with a round LCD display integrated with ESP32-S3 and features a touchscreen because I wanted to minimize input hardware for its operation. Once the start button on the bottom is pressed, the timer starts counting down 15 seconds before the first section starts. Each section is 35 minutes long. The transitions between the sections were given a 10-second countdowns, plus a 10-minute intermission between the second and third sections, just like the actual test. All the sections and transitions display both the remaining and elapsed times for the respective segments. When the entire session is complete, the unit goes into deep sleep. I used the ESP32-S3 library for the touchscreen functionality. A short touch on the touchscreen skips the timer to the start of the next segment, which works as intended. A swipe right was designed to go back one segment, but this doesn't quite work as hoped, and it often jumps to the second or third previous segment instead. I tried several debounce methods to finally get the short touch to work, but I haven't figured out how to make the swipe function work properly yet. The long press function does work to restart the whole session if needed while the unit is still active. More on this later. I wanted the unit to be portable and compact as my daughter often goes to various locations to take her practice exams, and so I purchased a cylindrical aluminum box from Amazon and used a hole saw on a drill press to create the opening for the display. The 1.28-inch round LCD display integrated with an ESP32-S3 on board is a fairly new offering from makerfabs.com, and it includes a touchscreen. However, in order to fit it into my package, I had to grind down the corners of the PCB, including a part of the microSD socket and most of the wireless antenna extension on PCB. But since I didn't intend to use any of the wireless functionality, that was okay. The portability of the unit also would require the use of a battery, and I used a 3.7 volt 400 mAh LiPo battery with a mini BMS board. This should be enough to give a few sessions of practice tests per charge, lasting about 2.5 hours each. I drilled a couple of 1/8 inch holes near the bottom of the box and used a jeweler's file to shape out a hole for a micro USB charge port for the BMS board. Then I attached the BMS board inside on the bottom with some hot melt glue to secure it and to prevent any conductive contact with the metal case. I drilled another 1/16 inch hole right beside it to make the LED status lights visible. It worked out without having to use any light pipe. I just filled the hole with a tiny bit of hot melt glue, and as you can see, it's functional. I put an extension of the reset button with a momentary micro switch on the bottom since I could not make an interrupt function to work to wake up the ESP board from deep sleep via the touchscreen. All the examples I could find online demonstrated that it's possible, but the entire sequence was within the setup section of the sketch and would not work for me since the call to go to sleep will be in the loop and I was not able to wake it up after making it go to sleep. A real-time clock functionality was in the initial plan, but it is not available on this particular ESP32 board, and in the interest of time and the space it requires to put it on the board, I decided to skip it this time. Pause and resume functionalities were also considered, but it was not practical for real-life simulation, so I decided to exclude them as well. Another minor glitch is the flicker, as you can see. I tried using a sprite image for the clock mark, hoping it would reduce the flicker problem, but I could not integrate it into the code to make it work. This is something I need to learn for future projects. For the display window, I found some glass lenses online that fit nicely into the opening I made, and I used some slow cure epoxy and secured the lens in the hole. I ended up using a lens that is flat on one side and convex on the other, as I found out that the touch functions worked just fine even with a thick lens on top. Well, that's it. It doesn't look as polished as I hoped, but the customer likes it and it's functional. And if you also have someone that is motivated to do well on their multi-sectional test, maybe you can put together something like this to show your support. Hope you enjoyed the video. Thanks for visiting.